In the previous video, we discussed about the general form of the logarithmic function, and we have seen how to find the rate of change of logarithmic function. Now we will talk about a special case of logarithmic function. As we know, a logarithmic function is of the form y is equal to log of x with base a, where a is a constant. If this constant is replaced by a very special or non-constant, that is e exponential, having value 2.71828. So log of x with base e becomes natural log of x, because log of e, the log of x with base e, becomes natural log of x. This is a special form of the general logarithmic function where the base a is replaced by e. Now let's see how to find the derivative of natural log of x. We can find derivative of this function by the same method or by using the definition as we did in the previous video, by finding the rate of change of basic logarithmic function. So there are two ways to find the rate of change of natural log of x. First is by using definition as we did earlier for this, but the second is just to use the rate of change of this function and then evaluate the rate of change of this function. If you want to find the rate of change of natural log of x by a definition, so you should watch the previous video of finding rate of change of the general logarithmic function, because there is no any difference in method of finding the rate of change of both of them. But we will use here the rate of change of basic logarithmic function, and then we will find the rate of change of natural log of x. Let's figure it out. As we know, the rate of change of logarithmic function of base a is equal to 1 by x into 1 by natural log of a and into the derivative of x on which it depends, so dx by dx is equal to 1. Now we will use this in order to find d by dx of natural log of x. So 1 by x as it is. What we are doing here is finding the rate of change of log of x with base e, that is rate of change of natural log of x. So 1 by x into 1 by natural log of a, that is base, so base is e here, into dx by dx, so 1 here, there is no need to write it again. So 1 by x, and we know natural log of e is equal to 1, so 1 by 1 comes out 1 by x. This is the derivative or rate of change of natural log of x, and it is really easy to find the rate of change of x if you know the rate of change of basic logarithmic function of any base, because a could be anything or any natural number or any real number here. Now let's take an example. Here is a function y is equal to natural log of x. So we are interested in finding the rate of change of natural log of under root x. All we have to do is just apply this formula 1 by x, that is 1 by under root x, and rate of change of under root x. This will be x to the power 1 by 2, applying power rule, half x half minus 1, and dx by dx, that is 1. So 1 by 2 x to the power minus 1 by 2. And we can also write it as 1 by 2 square root of x, and also this will be square root of x, and eventually this will be 1 by 2x, and this is the rate of change of this function. We do not need to apply all of this because we know when the function is something natural log of x, then the base is e, and we only have to apply the rate of change of any natural log of x is equal to 1 by x. So this is just a very easy method of finding the rate of change of natural log or natural logarithmic function. So in the next video we will talk about the rate of change of exponential functions. So stay tuned. Goodbye.